Okay, now in this third part of the introduction to trigonometry, we're going to take what we know about the definitions of the 6 trig functions, the trig functions for those 3 special angles, 30 degrees, 45, and 60 degrees. And now we're going to actually extend it to more angles, not just acute angles. And specifically, we're actually going to start graphing angles on the xy plane. So here I've graphed an angle, and if you see that it's on the xy plane here, so here's our x-axis and here's our y-axis. And if you look at a point, just for any time you're graphing in the xy plane, you could actually create a triangle by dropping down to the x-axis. That distance is y, and from there to the origin would be your value for x, and then now the hypotenuse becomes what we're calling here the r value. But essentially, this is still a right triangle, and so we can apply those same definitions for trig functions. And we can still continue to use the Pythagorean theorem when we need it. Okay, let's start by just trying to evaluate these trig functions. So what I have over on the right are the 3 angles that we've looked at so far, the 45, the 30, and the 60, but I've actually just plotted them on the xy plane. But essentially the right triangles are the same, and the values, the lengths on the side are the same. So first, sine of 45 degrees. So if we go over here to the 45 degrees, well, sine is opposite over hypotenuse, which in this new format is really the same thing as y over r. Either way you look at it, it's going to be 1 over square root of 2. Or if you rationalize the denominator, that's going to be square root of 2 over 2. What about sine of 405 degrees? So first is that when we're looking at bigger angles, we want to remember about coterminal angles. So to get a coterminal angle is basically saying that if you have an angle, and if you add or subtract a full rotation, which in degrees would be 360 degrees, for radians that would be 2 pi, is that you're going to get back to the exact same place. So if I go back to that top angle, this is 45 degrees, but if I rotated 45 plus 360, that would just end up with a line in the exact same spot. So the trig value can still be represented by that same triangle that we have there. So let's go ahead and find a coterminal angle here. So what I'm going to do is take 405 degrees, and since it's bigger than 360, I'm going to go ahead and subtract 360 degrees. And that's going to give us 45 degrees. And so because of what I had just drawn before, so 405 degrees would be starting here, going around. This would be 360 degrees plus 45. It would end in the same spot. So that means from trying to evaluate sine, that sine of 405 degrees is the same thing as sine of 45 degrees, which we had already found that, and so the answer is square root of 2 over 2. Okay, now let's do the same thing for the pi over 6 angle. So remember, if you convert this to degrees, and especially in the beginning, if you find that you always want to convert radians to degrees, that's okay. But just know that going forward in more math classes is that typically radians would be used exclusively. So you do want to get a little more comfortable using radians if you can. So pi over 6, though, if you convert it, is the same thing as 30 degrees. So that means you could look at this 30-degree angle right here in the middle, and tangent is opposite over adjacent, which if you think about it in terms of x and y, that's the same thing as saying y over x. And either way you look at it, it ends up being 1 over square root of 3. And then if you rationalize that, that ends up being square root of 3 over 3. What about tangent of negative 11 pi over 6? So again, we can look at coterminal angles. And you could convert this to degrees. I'm actually going to leave it in radians just to kind of show how to work with it in radians. So I have negative 11 pi over 6. So since this is smaller than 0, since it's negative, I want to add a full rotation. And a full rotation in radians is 2 pi. So the thing you want to get used to whenever you are working with radians is that getting common denominators is going to be helpful. So let me rewrite this. We've got a negative 11 pi over 6 plus, if I want to write that as a common denominator, I could multiply that fraction by 6 over 6. So that's 12 pi over 6, which is the same thing as, if I add those numerators together, 1 pi over 6, which is pi over 6. So tangent of negative 11 pi over 6 is going to be the same as tangent of pi over 6. And so if we look at that middle triangle that we have here, if we think about that rotation, so rotating negative means going clockwise. And so if I start at 0, if I start at 0, instead of going the positive direction, if I go the negative direction, I could go one full rotation. Wait, I didn't mean to go all the way around. Okay, what we had found here, so negative 11 pi over 6 is close to negative 12 pi over 6. And negative 12 pi over 6 would have been one full rotation, but in the negative direction. But what we found is that it's coterminal with pi over 6. So what's actually happening is that we're going in the negative direction, but we're stopping right here. And if we draw that ray that comes from the origin right where that angle stops, it's the same as if we drew that ray, that line here, at pi over 6. And so for that reason, when we're trying to evaluate the trig function of tangent of pi over 6 or tangent of negative 11 pi over 6, it's going to be the same answer. So it's going to be, in this case, positive square root of 3 over 3. Okay, so here's some examples of angles in standard position. So again, if we're going in a positive direction, that would be counterclockwise rotation. If you're going in a negative direction, that would be clockwise. So here's some examples of different angles in standard position. And standard position refers to using the XY plane and rotating in that direction. So rotating this way is positive. Rotating the other direction would be for negatives. And because this is going to come up later as well, just to review the quadrants. So if we're talking about the XY plane, there's 4 quadrants. And so usually what we're trying to figure out is if we draw an angle, which quadrant does it end up in? 1, 2, 3, or 4. And a quadrant angle is when it lands on one of the 90 degrees. And just to kind of review those quadrant angles, if it's in degrees, we would say 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then it goes to 360 degrees. And if it's in radians, it would be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. 2 pi here. I'm running out of space here. 2 pi. 2 pi. Let's draw each angle in standard position and then evaluate the trig function. So 60 degrees would be here. And if I'm going to evaluate cosine, what I would do is just drop that line down and then start to create my right triangle. So across from the 60 degrees is the square root of 3. Then the adjacent side becomes 1, and then the hypotenuse is 2. So using the cosine definitions of adjacent over hypotenuse, or x over r, we get 1/2. Now what about cosine of 120 degrees? So 120 degrees is in between 90 and 180. So that means that we would rotate around, and this would end up in quadrant 2. How could we find the value for the trig function at 120 degrees? Well, we could actually still draw the right triangle, but now that we're in a different quadrant, it'll change a little bit. So I can still just drop down that vertical to make my right triangle here. And we want to know what the angle is right here. We need that angle so that we can know what values to draw in here. So to figure that out, we could do 180 minus 120, which is 60 degrees. So if this is 60 degrees, well, opposite of the 60 degrees is the square root of 3, adjacent is 1, and hypotenuse is 2. There will be one difference here, and that's because we need to take into consideration when the x is positive or negative and when the y is positive or negative. So now the x is moving in the negative direction, so I actually want to change that 1 to be negative. Square root of 3 is still in a positive direction, and the hypotenuse is always going to be positive. So the answer here for cosine is going to be negative 1/2. Okay, so why can we just draw the triangle in this other quadrant? Well, one way to look at it, if you think about that definition in terms of x's and y's, now let's go ahead and look at 240 degrees. So 240 degrees is between 180 and 270, so that means I would rotate around and I would draw my angle in quadrant 3 this time. Let's try and draw the triangle. So how would I draw the triangle? It's really, once you draw that ray, it's going to be creating a vertical line always with the x-axis, never the y-axis. And so if we do that, we have kind of this little upside down triangle on the left here. What angle are we working with? Well, we had 240 degrees. If I want to know this little angle in here, I can take 240 degrees and then subtract 180 degrees, which is 60 degrees. So once I know that that little angle in my right triangle that I've just created in quadrant 3, since it's 60 degrees and I know the lengths of a triangle where one of the angles is 60 degrees, I can go and fill in all of those sides. So opposite of the 60 is still square root of 3, adjacent is 1, and the hypotenuse is 2. Now before I actually figure out, well, what is cosine of 240 degrees, you always want to check the angles. I'm sorry, not check the angles, but check the signs. So here, x is moving in the negative direction, so that's going to be a -1. Y is also moving in a negative direction, so that's going to be negative square root of 3. The 2, the hypotenuse is always positive, so I leave that alone. So cosine is now going to be -1/2. Okay, so you might be noticing the pattern here, but let's go ahead and work this out for that last quadrant. 300 degrees lands us here in quadrant 4. If we want to figure out the angle, because if we drop down, in this case I guess we're going up, a vertical line to the x-axis in order to construct our right triangle, we need to know that angle. So now we can figure that out by saying, well, we have 360 is one full rotation, but subtract that rotation we already did, the 300, means that that difference in there is going to be 60 degrees. Fill in our information again, square root of 3, 1, and 2. Now check the signs. Okay, 1 is moving in the positive direction, so I leave it as +1. Square root of 3 is moving in the negative direction. So that's going to be negative square root of 3. So what is cosine of 300 degrees? That's going to be adjacent, or the x value, 1/2. So this is how we can use those 3 special angles, 30, 45, and 60 degrees, to actually evaluate a lot more angles based on this. It's finding what quadrant an angle falls in, drawing the right triangle, and then figuring out what that angle is. And I'm going to talk more about that in another part. And I'm going to talk more about that later. Here's a diagram that's similar to what we did. So we kind of looked at different angles that involve 60 degrees. This is an example showing different 45-degree angles. So if we were looking at 45, 135, 225, or 315 degrees, we could do that same thing where we draw the triangle in the different quadrant, and in each case it's going to end up being a 45, 45, 90 degree triangle.